Today, the most advanced telescope in the world took a new step forward. The James Webb Space Telescope presented us with the earliest known objects in the universe that, in essence, should not exist. In August of 2025, this telescope captured an interstellar comet. The new images provided by the James Webb Telescope and the SphereX project gave us fresh insights into our interstellar traveler. It is ejecting carbon dioxide at a rate 8 times greater than that of water, a chemical signature that has not been observed in any comet before. Even more astonishing was the discovery of nickel without iron in its spectrum, which has become a true mystery for scientists. The appearance of these interstellar visitors breaks all known rules. In the past, comets were considered harbingers of disasters, and their bright streaks of light in the night sky frightened people. However, in 2017, astronomers made a discovery that surpassed all folklore expectations: Oumuamua. This was the first confirmed object from another star system, representing neither a comet nor an asteroid, but something in between. The cigar-shaped object, slowly rotating in space, accelerated in a way that physicists could not fully explain. Its origin was undeniable, and humanity received proof for the first time that fragments from distant worlds can reach us. 2 years later, the universe sent another guest. The comet discovered by amateur astronomer Gennady Borisov in Crimea looked different from Oumuamua. It was not a dead rock. It behaved like a classic comet, leaving trails of gas and dust as it moved past the sun. Yet, behind this familiar glow were traces of an alien birthplace. These interstellar objects, abbreviated as ISOS, represent something more than mere curiosities. Each of them carries a chemical memory of the world in which it formed, representing pieces of frozen time from the disks of dust and gas around other stars. Unlike distant exoplanets, which we can only occasionally glimpse in shadows, ISOS come to us, crossing our solar system like couriers. Each one whispers secrets of foreign chemistry and cosmic history. But in 2025, the third guest broke all the usual rules and made astronomers wonder if they were looking at the extremes of nature or something greater. What did James Webb reveal about the Borisov comet? When the telescope finally directed its infrared eyes at Borisov, astronomers received a unique opportunity, unknown to any generation before. This was a chance to unveil an alien comet using the most sophisticated tools ever created by humanity. From the outside, Borisov appeared ordinary: a glowing coma, a faint tail, a nucleus about 1 kilometer in diameter. However, Webb was designed to peel away the everyday shell and reveal the chemistry hidden within. What was discovered turned out to be both familiar and deeply alien. Clear signs of water vapor were noticeable, similar to those found in comets formed in our solar system. But alongside them was something astonishing. In the atmosphere of carbon monoxide, which reached levels that overshadow everything typically observed in the Oort cloud or the Kuiper belt, an extreme ratio of carbon dioxide to water was recorded. This suggested that Comet Borisov formed in conditions that were much colder and richer in carbon than those in which our planets formed. The study of dust added yet another unexpected aspect. The Webb telescope detected crystalline silicate minerals that only form at high temperatures, close to stars. However, these minerals were found inside a comet that had spent billions of years at the outskirts of its home system. Somehow, material had moved to the outer layers, been captured, and then ejected into interstellar space. This conclusion had profound implications. Planetary systems beyond our own do not simply replicate the architecture of our solar system. They mix and disperse materials in ways that we are just beginning to understand. Borisov became evidence that the recipes for world formation can vary significantly across the galaxy. However, even if Borisov was unusual, it still remained within the realm of the natural. The next interstellar visitor was about to push these boundaries to the limit. Dello 3 and Atlas. On the 6th of August, 2025, the usual rhythm of observations by the Webb telescope was disrupted. A call from astronomer Mark Kelly came through as urgent and brief. An interstellar comet named Tri-I Atlas was exhibiting behavior that defied explanation. Ground-based telescopes recorded its spectrum, filled with metallic elements, and its orbit was changing by the hour. Just a few minutes later, the team sent a request for interception, marking one of the rarest and riskiest maneuvers in the history of Webb. All carefully planned observation schedules were cast aside. The most powerful telescope ever created raced to catch up with a comet that was clearly about to defy all expectations. What Webb observed turned out to be more alarming than could have been anticipated. At a distance where most comets are at rest, Atlas was already showing activity, ejecting gas in massive volumes. However, it was not water vapor causing such activity. Webb's spectrograph confirmed a carbon dioxide to water ratio of 8:1, the highest ever recorded. For comparison, even the strangest comets in our system barely reach 70/100ths. Borisov, our last interstellar guest, contained an excess of carbon monoxide, while Atlas appeared to be composed almost entirely of carbon dioxide, as if it formed in a world where water was virtually absent. The chemical mysteries did not end there. As data continued to arrive, one anomaly became undeniable. Nickel lines were clearly marked, aligning across the spectrum, while iron, its constant companion in cosmic materials, was nowhere to be found. Every comet, every meteorite, every fragment studied in the solar system contains both of these elements. In fact, the typical ratio is 1 part nickel to 15 parts iron. However, here was a body in which nickel was found to be more than 40 times greater than iron. This was a ratio that nature had never demonstrated before, and its implications remained a topic that scientists preferred not to discuss openly. The mystery of acceleration. Even before the spectra from the Webb telescope were fully analyzed, researchers monitoring the object noticed something even more complex to explain than its peculiar chemistry. The orbit of the comet began to change. It no longer followed the smooth curve predicted solely by the laws of gravity. In just 3 days, the speed of the object increased by 0.12 meters per second squared. The acceleration was significantly greater than what could be explained by sunlight or ordinary gas jets. For a body more than 10 kilometers in diameter, it was akin to watching a large liner accelerate without engines or wind. The deviations were sharp. They occurred with jolts and small jumps, superimposed on the overall acceleration, as if something inside the object was turning on and off. The data was meticulously checked and rechecked. The parameters from Pan-STARRS, Gemini, and the Minor Planet Center confirmed them. No software glitches, no rounding errors. The acceleration was real. The curves only deepened the mystery. As Atlas rotated, its brightness increased and decreased with mechanical precision, every 7.2 hours, like clockwork. Ordinary comets rotate unpredictably, their speed changing based on gas evaporation. But Atlas did not drift or wobble. Its cycle remained clear, fixed, and unyielding. Some researchers attempted to model the signal as sunlight glints on a strange leaf-like surface. Others hypothesized about exotic jets of carbon dioxide, perfectly aligned to the rhythm. No explanation fit fully. The echo of this object was impossible to ignore. This first interstellar visitor also deviated from its predicted path, sparking years of debate about whether it was a comet, a fragment of rock, or something entirely different. But Atlas was larger, brighter, and its acceleration was more pronounced. Whatever force was acting upon it was rewriting the rules of comet movement, a story written in metal. long before the advent of telescopes and spacecraft. Humanity was already receiving messages from the sky, only they fell not in the form of glowing comets, but as metallic stones. More than 5,000 years ago, Egyptian artisans crafted delicate beads from a material that was unknown to them. Modern research has revealed the truth. These beads were made from iron meteorites, with nickel content that significantly exceeded anything that could be smelted on Earth. In the tomb of Tutankhamun, there was a dagger with the same cosmic signature found beside the body of the young king. For the Egyptians, this was celestial iron. Other cultures also left their stories. Babylonian tablets warned of fiery stones falling from the sky as omens of war and the fate of kings. Artifacts with high nickel content have been found throughout the Middle East, buried in royal tombs. They served as symbols of power and prestige. These metals were rare, their properties evoking confusion and even fear. People sensed that they held profound meaning, even if they could not explain it scientifically. In our time, astronomers studying the Comet 3I Atlas experience a similar unsettling feeling. The spectrum of this comet displays nickel without iron. Such a ratio cannot be produced by any known natural process. Ancient artisans regarded iron with high nickel content as a gift from the gods, while modern scientists view it as evidence of alien geology or something even more mysterious. The fear and reverence once associated with ritual blades and falling meteorites are rekindled in the light of this interstellar object. Debates among scientists are intensifying. In research centers in Boston, data obtained from 3I Atlas ignite discussions that grow increasingly heated with each new observation. Some astronomers suggest that the chemical composition of the comet can be explained by an unusual carbonaceous environment in which it formed. In such a system, nickel carbonyl could easily form and evaporate, while iron would remain bound in stable minerals. Others insist that such anomalies exceed natural models. One of the most active participants in the discussion is Avi Loeb from Harvard University. He has already gained fame for his hypotheses about the artificial origin of the object Oumuamua and points to the extraordinary ratio of carbon dioxide in Atlas. He highlights the spectrum of nickel without iron and mechanical acceleration as a combination of features that have not been observed in any known comet. His critics caution against hasty conclusions, reminding everyone of previous debates that outpaced the facts. Yet concern remains. Convincing data continues to emerge. Behind closed doors, even the most cautious agencies have begun to take an interest. In an internal report from NASA's Planetary Defense Office, this object was marked as a high anomaly. Although it was not considered a threat, it was being monitored with unusual diligence. The official stance remained measured. Additional data is needed, and extraordinary claims require extraordinary evidence. Nevertheless, many scientists in private conversations acknowledge that this object prompts them to consider possibilities they were not prepared for. What does this mean for us? For scientists, Tri-I Atlas is not just an interstellar curiosity. It is a reminder that our solar system is not a model for the entire universe, but merely one of countless variations. Its chemical composition suggests that worlds can form in significantly colder and stranger conditions, where carbon dioxide predominates over water, and nickel exists outside of its familiar iron. If such places truly exist, there may be planets with climates and geology unlike anything we know. What can we imagine? However, these anomalies concern not only data charts, they touch upon something much deeper. Humanity has always sought meaning in the heavens, and objects like comets evoke both awe and anxiety. The unexplained acceleration, the mechanical rhythm of light, and the violation of known laws of physics are not merely scientific mysteries. They are challenges that compel us to think. Are we witnessing the extremes of nature or traces of intelligent activity? In this uncertainty lies both excitement and fear. If the comet is a natural object, it expands our understanding of the possibilities of planetary systems. If not, then perhaps we are witnessing new evidence for the first time that we are not alone in the universe. In any case, it calls into question the quiet assumption that our corner of the cosmos is typical or safe. The comet, as a messenger from afar, has arrived bearing chemistry that should not be present in such objects. It moves in a way that no known orbit predicts. Is it a natural phenomenon or artificial? This question finally forces us to confront what humanity has long avoided. What else lies hidden in the darkness of space,